Okay, grade 8, chapter number 10, 8, 6. It's one of those three numbers. 10, chapter 10 on algebra. The second thing we are learning today is how to represent equations, or how to solve algebraic equations using modeling. So the first couple questions here on your review are just basic stuff you should know by now. And the first 6 questions are true, false. So the first one says 2x is equal to 2 plus x. The answer is false, because 2x is actually 2 multiplied by x, or 2 multiplied by x. And the reason why we don't show multiplication when we do coefficients is obviously because this multiplication symbol and this x look similar, so we would never write it this way. We would always use 2 bracket x to show multiplication. Or, since it's a coefficient of 2 and a variable of x, we always put the variable first, and then your variable second, and your coefficient of 2 first. Your second question says x plus 3 is the same thing as 3 plus x, and the answer for that is true. And if you look down at my wall here underneath my board, I've written down the associative property of math. Pardon my handwriting, but the associative property of math. And what this means is the order in which you add or multiply does not affect its product. So in the case of x plus 3, let's pretend x was 2. So 2 plus 3 is the same thing as 3 plus 2. The order in which I add them together does not affect its sum. So therefore, even if it's algebraic, like an x instead of a 2, the sum of those two would be equal. So the answer is true because of the associative property. Question 3, x over 2 is the same thing as x divided by 2. That's true because x over 2 is represented by half of x. And to get half of x, we would divide it by 2. It's a little hard one to kind of give a proof, but they are the same thing. Also, you could also put half of x is also this, or half of x is also that. But those two we don't delve into too greatly in grade 8, but grade 9 we would. The next question, 2x minus 4 is the same thing as negative 4 plus 2x. The best way to show that they are the same, because the answer is true, you could either say the associative property, but the best way that I like to show is model them. So there's 2x and negative 4. And there's negative 4 and 2x. The only difference between those two is in the first one I put my variable and my coefficient first, and I put my constant term second. And in the second side, I put my constant of negative 4 first, and my 2x is second. But they both are the exact same thing, and the best way to show it is through modeling. So the answer is true, they are the same thing. Question 5 says a quarter of a number can be expressed as x over 4. It's important to know that x over 4 is the same thing as x divided by 4, or there's x divided into 4 parts, and 1 part is what you have. So x over 4 is a quarter of a number, and therefore is true. Question 6, the hard question, and not a lot of people probably got this, but it's more like an FYI question than something I'm really going to assess you on, but it does show great understanding. So 0.2x is the same thing as 2/10 x. And 2/10 in lowest terms, if I think of it as a fraction, is 1/5 x. And 1/5 of x, if I think of it as multiplication, 1/5 multiplied by x, or x over 1. Since we understand multiplying fractions, we would multiply the numerators. 1 times x is x. 5 times 1 is 5. So therefore, all of these are equal. So x over 5 is the same thing as 2/10 x. So the answer is true. Question 7 says, for question 7 to 10, write the equation and solve by inspection. So what you have to do is interpret what this says. And each of these is an x. That's an x there, that's an x there, and that's an x there. So really, we have 3 x's is equal to, these are negatives, so we have negative 6. So now that we have it interpreted, we say 3 times what number is negative 6? x must be negative 2 by inspection. 3 times negative 2 is negative 6. So each of these must be worth negative 2. So negative 2, negative 2, negative 2 is negative 6. Next question, question 8 says x minus 1 is equal to negative 4. So once you've interpreted it, your next job is to then say, well, what number do I take away 1 from to end up with negative 4? And the answer would be x equals negative 3. Or this x must be worth 3 negatives. Question 9, 3 plus an x is equal to negative 1. Now this screws up a lot of kids because they're not used to, in grade 7, you're not used to putting the constant before your variable. So normally you would have said in grade 7, 3 plus x, or x plus 3, right? But you need to know, because of the associative property of mathematics, that 3 plus x and x plus 3 are the same thing. It's okay to put your constant first in your expression. So what 3 plus what number would give you negative 1? Well, we know that that x has to be negative 4 in order for the sum of 3. So 3 plus negative 4 is negative 1. Or this has to be 4 negatives. And your last question, question 10, says negative x is equal to 3. Now the other way to say negative x is the opposite of x. The opposite of a number. The opposite of a number is 3. So what is that positive value of the number? Or what is the number if the opposite is 3? The opposite, or the number itself, must be negative 3, because the opposite of negative 3 is 3. So x must be a negative 3. That's a little trickier one. It deals with the negative values of x. Question 11 says, for questions number 11 to 16, model the equation and solve by modeling. So, x minus 5, this is x. And this is a constant of minus 5, is equal to negative 2. So our goal in algebra, as Marcus will tell you, is to isolate the variable, or to get x by itself. Isolate the variable. And the thing that we have here is we have this negative 5 that we have to get rid of. Numerically, we have to get rid of that negative 5. So what we're going to do is we're going to add a positive 5 to this side, because we know from grade 7 that all of these will make 0 pairs, giving me nothing. But in algebra, in order to maintain the balance of equality, whatever you do to one side of an equation, you have to do the same thing. So if I added 5 to one side, I must add 5 to the other. And here we have 2 0 pairs created, and 3 being left. So the picture I have to draw is x equals 3, and if you haven't drawn it separately, please make sure you do. And the last thing I do is interpret it as being x equals 3. Most people forget to redraw the second scale. So if that's you, make a note of it. Make sure you draw the scale. Question 12, negative 5 plus x equals negative 2. So your scale, put your constant first. It's okay to have a negative 5 there, and then a positive x equals negative 2. Now some people might have drawn this. If you did, it's not wrong in terms of the value, but it's wrong in terms of what it says. So make sure you interpret it properly. The first thing you're going to do is get rid of the constant by adding 5 to both sides. To this side and to this side. Here, all 0 pairs. Isolating the variable, becoming just x. Over here you have 2 0 pairs, leaving you with 3. And this scale says that x has a value of positive 3. Question 13, a negative x equals 4. So a negative x is going to be a non-shaded in x equals positive 4. And if the opposite of x is positive 4, then x must be its opposite. A positive x must be a negative 4. and therefore x equals negative 4 is my solution. Question 14, negative 2x equals negative 6. So 2 negative x's, or negative 2x, equals negative 6. Therefore, here's your drawing. Now watch. A lot of people get this wrong. If 2 negative x's equals negative 6, then each of these negative 6's must be equal to negative 3. And therefore, there's your therefore symbol, a positive x is equal to positive 3, or x equals 3. Now, question 15 says 8 plus x equals negative 6. So 8 is your constant and is represented by 8 integer chips. And a positive x equals negative 6. So remember, the goal is to isolate the variable, so I want to get rid of the constant. And in order to do so, I'm going to put 8 negatives on this side and 8 negatives on this side. Therefore, x is isolated, and I am too lazy to do this again. That's going to be just this. Save you some time. And this says x is equal to negative 14. Question 16. Now, here's the thing you need to understand. That x over 3 is not what it says, it's what it looks like. And x over 3 really represents x divided by 3, or more importantly, a third of x. And if you can read x over 3 as being a third of x, drawing it makes sense. Because that's what a third of x would look like. So a third of x equals negative 4. The next thing you need to ask yourself is how many of these would equal this? And the answer is I need to have 3 of them. So your next picture is to draw 3 of these. And if you tripled that side, remember that in order to maintain balance, since this is what the side originally had and I tripled the left, I have to triple the right. And I end up with, this is going to become a full x. And this, I'm going to be lazy, is going to become 12 negatives. In which case, the full x has a value of positive 12. Negative 12. Oops. Negative 12. Yeah, my bad. Question 17, 18, 19, and 20 say solve by modeling. So the first thing I'm going to do is realize that this is my constant. So if I had to reinterpret this picture, I know that it's negative 2x plus 1 equals 3. And when you have a two-step algebraic equation, you learned in grade 7, the easiest thing to get rid of first is the constant. What we're going to learn in grade 8 and grade 9, more in grade 9 than grade 8, is that you don't have to get rid of the constant first. It's just easier when you have a basic understanding of algebra to get rid of it first. Here we go. So the first thing I'm going to do is I'm going to add a negative 1 to both sides. And the reason why I'm going to do that is because it gets rid of my constant and is one step closer to isolating the variable. So by putting a negative 1 on both sides, I end up with 2 negative x's is equal to positive 2. Divided into 2 scales. If 2 negative x's equals negative 2, then each of these negative x's must be equal to a positive 1. Or the opposite of x is 1. So therefore, x itself must be negative 1. If the opposite of x is positive 1, then x must be negative 1. Question 18. If I was to interpret it, this is what it looks like. If I asked you to interpret question 18, that's what the model looks like. But what do I do first? The first thing I'm going to do is get rid of the constant, which is this negative 3. I'm going to do so by adding 3 to both sides. So by adding 3 to both sides, I get rid of my constant. My next picture has to be a negative x is equal to, now notice there's no 0 pairs here. A positive 3 and a positive 3 is just going to be a positive 6. Right? Positive 6. And if the opposite of x is positive 6, then a positive x must be equal to negative 6. And therefore the solution is x is equal to negative 6. Question 19. That's my constant, so the first thing I'm going to do is put negative 2 on both sides. Because I know that's my constant. It's the first thing I should get rid of. My next picture is half of x is equal to negative 7. But I don't want to know what half of x is. I want to know what all of x is. So my next picture is to show that I'm going to double this side. And I'm going to double this side. Oh, God. Well, I'll just draw it. I'm not lazy. Negative 7. Negative 7. And my final picture is that these two halves combined are going to make a full x. Now I'm going to be lazy. And those 14 negatives are just 14 negatives. And what does this say? It says that x is equal to negative 14. And finally, question 20. Now, what makes this question 20 so different than anything you saw in grade 7? It's twofold. If I was to interpret it, this is what it looks like. And normally in grade 7 algebra questions, you have the variable on this side and your answer on this side. But what we have here is we just have it switched. But it's no big deal, because what you know is this 4, which is right here, is your constant. It's your constant, which means it's the first thing I get rid of. So from a modeling perspective, I'm going to put 4 negatives here and 4 negatives here, getting rid of my constant. And I end up having a third of x is equal to 2 negatives. Because over here, by putting 4 negatives there, I make 2 0 pairs. Leave me with 2 negatives. And I don't want to know what a third of x is. I'm going to triple this side. So I'm going to have 1, 2, triple this side, and triple this side. When I triple this side, all of these together are going to give me the full value of x. And over here, I have negative 6. And what does it say? It says that negative 6 is equal to x, or if you want, you can flip it back around again and say x is equal to negative 6. Okay, your last 4 questions says it does not give you the picture, it gives you the equation. You're to interpret it as a model and solve it modeling. So negative 5 looks like this. So this first part here is this part here. This second part here is going to look like this. The equal sign, which is right here, is going to look right here. And your 3 is going to be over here. Okay? I guess I should have highlighted this green, shouldn't I? That's your negative 2x. Okay. So now that I've interpreted it as a drawing, I know that my constant is negative 5. So in order to create, work towards isolating the variable, I want to get rid of that. And the way to do that is to add positive 5 to both sides. This side and to this side. And we know that it's going to maintain balance because putting something on one side and doing the same thing to the other maintains balance. 0 pairs. My next picture is 2 negative x's equals, I'm getting lazy here, so I'm just going to do this. And then if 2 negative x's equals 8, then each of these negative x's must be 4. We're going to divide it into 2 separate scales. And if the opposite of x is 4, therefore, a positive x must be the opposite of that, which is negative 4. And therefore, x equals negative 4. Question 22 says 10 minus 2x. So, the constant of 10, by the way, I'm going to wow you with my brilliance here. There's 9, and there's 10. I guess I'm not going to really wow you. Minus 2x is equal to 9. So the first thing I want to get rid of is my constant, which I have to identify as the positive 10. It's the side of the equation that has the variable. So in order to get rid of that constant, I'm going to put a negative 10 on this side. And whatever I do to one side, I do to the other. And a negative 10 on the other. This creates my zero pair with my constant, leaving me with 2 negative x's is equal to, watch this now, negative 1, right? Now here's where it gets complicated with the drawing. And I'm okay if you didn't draw it properly because it doesn't really matter. Then each of these negative x's is equal to half a negative, right? Well, if 2 negative x's is equal to negative 1, then each of these must be worth half of a negative, or a negative half, which means that a positive x is equal to a half, or x is equal to a half, or, well, you can, but it's too hard, so I don't bother. 0.5. Whichever one you want to put. Decimal or fraction form's fine. Question 23 says negative 2 plus a third of x. So negative 2 plus a third of x is equal to 1. First thing you want to get rid of, Brex, is, which is what? Negative 2. So I'm going to add 2 to this side. And whatever I do to one side, I do the exact same thing to the other, leaving me with a third of x is equal to 3. How many thirds of x do I need to make an x? I need 3 of them. So I'm going to triple this side, and I'm going to triple the other side. So here we go. 3 thirds of x is a full x. Too lazy. And therefore, x is equal to 9. We good on that? And your last question, question 24, says 4 plus a fifth of x. That's a little bit longer. So 4. Now a fifth of x looks like this. Equals negative 1. First thing I'm going to get rid of is my constant, and as Brex would tell you, the constant's 4. So I'm going to put a negative 4 on this side and a negative 4 on the other, leaving me with a fifth of x is equal to negative 5. Now, since I don't want to know what a fifth of x is, I want to know what all of x is, I have to do what to both sides? Multiply both sides by 5. So here's what it looks like. I'm going to press pause and draw it for you. So by multiplying both sides by 5, this is what I end up with. All of these together is going to equal the full value of x. And all of these, I am no way going to draw this again, is 25 negatives. So x equals a negative 25.